This is the video for section 1.3, and this is where we'll start talking about the trigonometric functions. So in order to talk about those, we're going to start by looking at a point on the graph. So this is a generic point. It could be anywhere on the graph. And then we're going to look at the angle whose terminal side goes through the origin and through that point. So we're looking at an angle theta. So the vertex of the angle is at the origin, or the point 0, 0, and then it goes through the point x, y. In this picture, there are some distances that we can find. First of all, we know the x-coordinate of the point, so we know that this distance from the origin to here is x. And we also know the y-coordinate of the point. So the distance here from the origin up to this point is y. The other value that we need to know is the length of this line segment from the origin to the point. To find that, we're going to use the distance formula. And you might remember this one from college algebra. This is where we had 2 points, x1, y1, and x2, y2, and this is how we found the distance. So in this case, we want to find the distance from the origin, so the point 0, 0, to the point x, y. So if we plug in those values, here we'd get x minus 0 squared. Here we would get y minus 0 squared. And if we simplify that, we just get the square root of x squared plus y squared. Now for trigonometry, instead of calling this distance d, since we're going to end up talking a lot about circles and the xy will be a point on the circle, we're going to call this distance r. R stands for radius. But for right now, we just need to worry about how to find that distance. So the distance from our point to the origin, r, is the square root of x squared plus y squared. Then using the x, the y, and the r, we can define our 6 trig functions. Each of these is just a ratio of 2 out of those 3 values. So sine of theta is y over r, cosine of theta is x over r, tangent of theta is y over x, and then we have 3 other functions. Cosecant of theta is r over y, secant of theta is r over x, and cotangent of theta is x over y. Now these are all functions. What we have is abbreviations for the names of these functions, and then the theta, which was the angle in our picture up here, the theta is actually the input value for each of these. So the actual names of these functions, if we write them out, this one is sine, this one is cosine, this one is tangent, this is cosecant, this one is secant, and this one is cotangent. The 3 main trig functions are sine, cosine, and tangent. Cosecant, since it's r over y instead of y over r, it's actually just the reciprocal of sine. So if we knew the sine of theta, we could get the cosecant just by taking the sine value and flipping it over. Same thing with cosine and secant. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Now we're going to look at an example where we have a specific point on the graph, and we're going to find the value of all 6 of our trig functions. So the point we have on the graph is 12, 5. So here's our point, and our angle theta could be any angle that has the x-axis as an initial side and this line as the terminal side. Now, if I want to find the values of my 6 trig functions, I've got the x is 12, the y is 5. I need to find the r. So I'm going to use my formula that r is the square root of x squared plus y squared. And I'm just plugging in the x and the y. And when I do this, I'm always going to put the x and the y in parentheses. That way, if they're negative, I don't have to worry about whether the negative goes in or out, inside or outside of the parentheses. And when you're working this out, when you're squaring these numbers in here, whether they're negative or positive, when you square them, you always get a positive value. So 12 squared would be 144, 5 squared would be 25. That gives us the square root of 169, which is 13. So our r is 13. Now that we have the x, the y, and the r, we can find the values of our 6 trig functions. And we're just going to use these definitions up here. So I'm going to start with sine of theta. That is y over r, which would be 5 over 13. Cosine of theta is x over r, so that would be 12 over 13. Tangent of theta is y over x, that would be 5 over 12. Then if I want to find the values of the other 3 functions, I can either use the definitions up here, or if I can remember which one goes with which, I can just take each one of these values and flip it over. So for this one, sine goes with cosecant. So for cosecant of theta, I could just flip this over. That would be the same as doing r over y. The reciprocal of cosine is secant. So secant is r over x. That would be 13 over 12. And for cotangent, it's the reciprocal of tangent. So it would be x over y, or 12 over 5. As I was saying before, these are actually functions. So we never want to see the abbreviated name for the function written without an angle or a number after it. If it helps you, you can put these in parentheses for now. And just remember that what comes after the name of the function is your input value. And in this case, it was this angle. And we don't necessarily have to know the measure of the angle in order to find out the values of these functions. We just have to know the x, the y, and the r. Let's work through another example. In this one, our terminal side of our angle passes through the point 8, negative 6. There's our point. So our terminal side of our angle is going through that point. And again, I could draw my angle theta. I could draw it as a positive measure angle, which would go around this way, or I could even make it a negative measure angle, so it would be going clockwise. So I have the x, which is 8. I have the y, which is negative 6. I still need to find my r. So I'm just going to plug in the 8 for the x and the negative 6 for the y. And like I was saying on the last one, when we square these, we're always going to get positive numbers by squaring. So when we square negative 6, we get positive 36. That gives us the square root of 100. So that gives us an r of 10. So we have x equals 8, y equals negative 6, and r equals 10. Then for our 6 trig functions, sine of theta would be y over r, which would be negative 6 over 10. we could reduce that down to negative 3/5. Cosine of theta is x over r. That would be 8 over 10, or we could reduce that down to 4/5. Tangent of theta is y over x. That would be negative 6 over 8, or that would reduce down to negative 3/4. For our other three functions, we can use the definition, or we can just remember which one goes with which. So sine and cosecant go together. Cosecant is sine flipped over, so it's r over y, which would be 10 over negative 6, which would reduce down to 5 over negative 3. So you can see, comparing these two, that cosecant is just the reciprocal of sine. Then for secant, same thing. It's r over x, which would be 10 over 8. That reduces down to 5/4, and that is just the reciprocal of cosine. And notice with these two, if you're trying to remember which one goes with which, we don't ever have ones where we have the same letter to start ones that are reciprocals. So these two, one has the S, one has the C, same thing here. This is a C and an S. And then for tangent, its reciprocal is cotangent. So that would be 8 over negative 6, or we could reduce that down to negative 4/3.